Hi, I'm Jay Richards with the Discovery Institute, and we are here at Discovery Institute's COSM Technology Summit 2023 in beautiful Bellevue, Washington. And I've just heard a talk from Stephen Balaban, who was talking about, a couple of things I'm actually going to ask you about. First of all, Stephen, good to be with you. Good to meet you.
Thanks for having me.
Yeah, so you talked about something at the beginning of your presentation, the rise of autonomous AI agents. What is that exactly?
Yeah, so I think what we've seen is with the launch of ChatGPT in November of last year, the sort of very early innings of a new type of technology that's going to really fundamentally restructure the way that humans work. So I think flash forward 15 years from now, most people will have a AI assistant or AI agent that's sort of like Samantha from the movie Her, where they're going to be able to not just interact with you, give you advice, give you both relationship advice as well as the better advice than maybe the best management consultant out there today, but also generate images, video, even full-length feature films for you. And these are going to be people that virtual people almost that you interact with in the same way that you interact with your colleagues and coworkers today. You're going to interact with them over Slack, over phone calls, over video conference calls. But they're going to be sort of these agents that can work 24/7, 365. They don't ever need to sleep, and they're always there to help you with your work.
And so, unlike what we're just starting to experience, which are these chatbots, which are presumably generic, is the idea that you would basically precisely fine-tune your particular AI agent so that it's got the parameters that you want. That's the idea of it being autonomous?
Yeah, the general idea is this. As these large language models have progressed, they've gotten more and more intelligent. So we've gone from sort of very basic level of language understanding to what most people would probably consider to be almost a high school level of language generation ability, and even beyond, especially with regards to the breadth of knowledge that these large language models exhibit. And I think that if you kind of flash forward 10, 15 years and this stuff gets to college level and PhD level and beyond in terms of its ability to its ability to reason and come up with these answered questions, you're going to be able to give it tasks, and it's going to be able to sort of run a little bit of a loop and ask itself, all right, well, what are the things I need to do? Let me first collect my thoughts. Let me first outline step by step what I'm going to be doing. And then let me go and execute those tasks in a row. Go 1, 2, 3, 4, 5 down the list. And then, hey, let's check my answer. Let's make sure that I've delivered the actual presentation that I think is going to be a good presentation for my, the person who's prompted me to generate this for them. And they're going to double check their work and then come back to you. And so that's the kind of autonomy that I'm talking about.
Yeah. So it's still based on a prompt essentially, but like a really good assistant that it might take them a couple of days, then they come back to you. That's the idea.
It'll still likely be based on prompts. But the prompting could also be not explicit. There could be sort of an implicit prompt, which is to say that you get back and maybe you've received an email, and that an email in your inbox is in a sense an implicit prompt for action or response, and that's what I mean by autonomous.
Gotcha. Okay, but you talked about these two key hurdles, which is I think this kind of central part of your presentation. What are those, and why do they matter, and what do you think? What needs to be done about it?
Yeah, so the two key hurdles from like here to that super future that I think is around the corner. One of those is a big one, which is how well are the current present day models going to be scaling up with the amount of computation, right? So far, pretty well, right? So far, what we've seen is that the more computation you throw at these problems, and the larger these large language models are, the better they perform. And I think that's still got, if you will, some juice to squeeze left.
So what's happening for the layperson if you go to ChatGPT or Google Bard or something, you prompt it, what's happening in the infrastructure right now?
Yeah, so well today, it's important that there's two steps to this, right? So there's the training step, which requires thousands upon thousands, even tens of thousands of GPUs.
The average end user just presupposes that, right?
And then there's the what's called the inference step, which may only require 1 to 8 GPUs depending on the particular model being run. And basically, the neural network that's been trained is run. It takes in as input a tokenized version of the prompt that you've given it, meaning just, let's just say it translates from English into machine language, which is these sort of vectors of tokens, and then it generates text that it thinks is sort of a good response to this prompt. Okay, so that's what's happening today. The problem that I'm sort of mentioning is just, as we scale with the models on the training side, right? As we train them with more data and as we train them with more GPUs, is it going to continue, or is there going to be some pretty steep, let's say, decline, diminishing marginal returns?
Right.
Okay. So, but now let's just say that things continue to scale. We've got some more juice to squeeze out of this, maybe another 2x or 4x in capabilities.
Okay.
I'm just going to make a number up.
Yeah, sure.
There's another bottleneck that we're seeing in the world today, which is not just a shortage of AI chips, but actually, a shortage of overall megawatts and our ability to properly host these massive GPU supercomputers that are used to train models today.
So this is this isn't a processing problem. This is a power problem.
Yeah, this is a power problem, and it's a general digital infrastructure problem.
Okay. So what do you think? What needs to happen then to get to this amazing future 15 years out that you're describing?
Yeah, I think one of the prompts that I kind of said in the room is that really it's up to everybody in the room here. It's up to the world's capital allocators, the world's entrepreneurs, and the world's engineers to sit down, come together, and say, hey, look, let's build some larger models and really see how far this current light can go. And 2 is let's make sure that we're making the investments to build this sort of infrastructure that we need to power this, in the same way that we needed to make a lot of infrastructure investments to put railways across the United States and electrify the United States and put digital infrastructure so that everyone has broadband internet or wireless access. There's going to be sort of this new stage of, if you will, industrial build out or infrastructure build out.
So you mentioned the idea of a computational utility, and I know that Lambda is a GPU cloud as you described it. So explain that exactly.
Yeah. So the word computational utility, what I'm really trying to sort of like get at that is get at what that is. What happens when, in the same way that water and electricity have become utilities, meaning that it's a completely fungible joule or a completely fungible gallon of water or a completely fungible megabits of data downloaded off the internet, right? And what happens when the same thing happens for flops, for floating point operations?
Okay.
And that's what I mean by a computational utility. I think that's the direction, generally speaking, humanity is going to be going in with regards to how we do computation. Today Lambda is a GPU cloud, but I think that if you flash forward again a couple of decades, you're going to start to see that these clouds and all this stuff sort of evaporate away, and you just end up with this raw access to pure flops that people are getting. And then I think that there's some layer. There's still lots of room for layers on top of that raw underlying compute, in the same way that people use the underlying power utilities to build data centers or steel power plants or electric car charging stuff. There's always a lot of stuff to do on top of the power.
So are you optimistic or pessimistic about this happening?
I'm an inherently optimistic person. I think that most entrepreneurs that you would ever talk to, they have to be inherently optimistic people, because otherwise it's just too hard. It's just too hard.
That's right. If you were a pessimist, you wouldn't be an entrepreneur.
Exactly.
You'd be a bureaucrat.
You wouldn't start.
Yeah, really good stuff. Stephen Balaban, it's good to meet you. Thanks for joining us.
Jay, thank you.
Yeah. I'm Jay Richards, and we're at COSM 2023. Thanks for joining us.